Dear student, welcome to all of you in my online maths video class. Today we will discuss a new topic of the sequence and series, and that is arithmetic mean. Arithmetic mean. Before this topic, we discussed about the how to find the nth term of the arithmetic progression and how to find the sum of the nth term of the arithmetic progression. This is the theoretical portion before given exercise 10.4. The name of the topic is arithmetic mean. Dear student, if we take a two number a and b, then its arithmetic mean, which is represented by am, arithmetic mean here is equal to a plus b by 2. Okay, or we can say here arithmetic mean is the average of these two numbers a and b. If we take arithmetic mean this, then here a plus b by 2 and b, they are in AP. At the place of this, if we represent a means arithmetic mean a, then A1, A, capital A and B will be in the form of arithmetic progression. In this way, by the property of this, we can write here capital A minus small a is equal to B minus A here. So we can also represent it in this form. Capital A plus A is equal to A plus B. Here 2A is equal to A plus B and A is equal to A plus B by 2. It means if we have two numbers A and B, then the arithmetic mean will be average of these two numbers. Okay. In this way, the topic whatever we are going to discuss, that is the arithmetic mean and how we find that by taking the average of two numbers. Not only one arithmetic mean, we can take more than one also. We can take 4, 5, 6, 7 up to n arithmetic mean we can take. Here it is given if two numbers a and b, so we can insert a number capital A between them so that small a, capital A and b should be in arithmetic progression, and this capital A is called arithmetic mean. Okay. In other word, we can also say that if small a, capital A and b are in AP, then A is called the arithmetic mean between these two numbers small a and small b. Here it is proved that how the value of A is equal to average of the two numbers small a and small b. So in this way we can say that the arithmetic mean of the two numbers small a and small b is the arithmetic mean, the arithmetic mean between two numbers small a and small b, that is A is equal to A plus B by 2. Okay, it is very easy to prove that how we can find the arithmetic mean between these two numbers A and B. This is the only one arithmetic mean, but we can find more than one arithmetic mean between these two numbers, and how we can find, here I am going to explain. If we have an arithmetic mean between two numbers A and B, then they can be in this form. Here if we have two numbers A and B, then we can find more than one arithmetic mean. Let this is the first arithmetic mean A1, this is the second arithmetic mean, this is the third arithmetic mean. Similarly we can find n arithmetic mean between A and B. Okay. Now here the total number of arithmetic mean is n, and here two more number. It means we can say in this case total number of terms is equal to n plus 2. Try to understand. Total number of here arithmetic mean is n arithmetic mean, and plus 2 number more. First number, second number. We can say that total number of terms is equal to n plus 2. And here all the numbers will be arithmetic progression. All these numbers will be in arithmetic progression. So here the total number of terms is this. First term is what? Here in this case first term is small a, and last term is what? That is small b. Okay, then here we know that last term is equal to, since last term is equal to a plus n minus 1 into d. Using this formula, we will use this formula and try to find the value of the common difference. Here in this way we can write this. B is equal to a first term plus total number of terms, that is n plus 2, n plus 2, a plus n minus 1. Here at the place of n, total number of terms is what? n plus 2 minus 1, a plus n minus 1 into d. Here let d is common difference. Here for this situation, let d be the common difference. Then we can write here b, if you transfer this side, it will be b minus a is equal to n, 2 minus 1 will be plus 1 into d. Or we can write here d is equal to b minus a upon n plus 1. It means in this case the common difference will be b minus a upon n plus 1. Okay, it means if we want to find the second term, what is the second term? That is a1. It is a plus d. Why? Since we know that if a is the first term and d is the common difference, then the first term will be a, the second term will be a plus d, the third term will be a plus 2d, and like that we can find the next term. Here the second term, the first term is a, and the second term how we get? By adding the common difference. So here the first term and the common difference, if we add, we can find that a plus d, and what is the value of d? That is b minus a upon n plus 1. Similarly the third term is what? Third term, which is a2. Here this is first term, t1 we can write first term, t2 second term, t3 third term, and similarly here it will be tn plus 2th term, last term, tn plus 2, because total n term n plus 1 plus 2, it means total n plus 2 term here. So second term will be a plus d, a plus 2d. Now a plus 2d means a plus 2 into b minus a upon n plus 1. Similarly we can get the nth term also, nth term, that is an. Okay, and an will be a1 means a plus d, a2 means a plus 2d, then an means a plus nd, and it will be a plus n into b minus a upon n plus 1. Like this way we can find its nth term also. Okay, now a plus n into b minus a upon n plus 1. Now here we can find the nth term and the terms before this, that is first term, second term, third term, using the first term of this arithmetic progression and last term of the arithmetic progression b. Okay, and we know that what is b minus a upon n plus 1? This is the common difference from this formula. Okay, now here I am trying to find the sum of the n arithmetic mean. The sum of the n arithmetic mean. Now here I am going to find the sum of n arithmetic mean. the sum of n arithmetic mean. Dear student, here I explain. This is all. The first arithmetic term is A1, the second arithmetic term is A2, the third is A3, up to the last arithmetic term is arithmetic mean. First arithmetic mean, second, third. Here we just find n arithmetic mean between the two numbers A and B. But here I want to find the sum of n arithmetic term, and the n arithmetic term is A1, A2, A3, An. Okay. Here I want to explain one formula. We know that Sn, sum of n term, is equal to n by 2 into first term into last term. First term plus last term means A plus n. Formula A plus n. First here we want to find Sn. Then what is the first term? The total number of term is n, no problem, n by 2. The first term is A1 and the last term is A. Okay. The first term is A1 and the last term is An. Then how we find the first term? The first term is here we just get how. Let this is the equation first. And when we explain A1, A2 up to An and here B, then in this case we find that common difference is equal to, in this case we find that common difference is equal to b minus a upon n plus 1. B minus a upon n plus 1, this is the common difference in this case. It is earlier put. It is put. So here if you take the A1, and what is A1? A1 is the second term. A1 is what? Second term. And second term is what? First term plus common difference. So here it is A plus B minus A upon n plus 1. If we calculate, it will be n plus 1. And here A into n plus 1 plus B minus A. So it will be An plus A plus B minus A upon n plus 1. A and A will be cancelled and it will be An plus B upon n plus 1. It means the first term will be what? An plus B upon n plus 1. What is small a? Small a is the first term of this arithmetic sequence, arithmetic progression, and B is the last term of this arithmetic progression. Here A and B is the two number in which we have n arithmetic mean, which is A1, A2, An. And finally the sequence will be in the form of arithmetic progression. Then how we get the A1? Here a simple method, and finally we get in this form A1 is equal to An plus B upon n plus 1. Similarly here we can get An also. N is equal to A plus ND. Okay, and A plus N and D is what? D is what? What is the common difference? Common difference D means, here D means what? Common difference B minus A upon n plus 1. Okay, now let us calculate this. If we calculate, then we find that its value will be A plus Bn upon A plus Bn upon n plus 1. We find its value like this way. Here we get, after calculating, A plus Bn upon n plus 1, and here we get A1 like that, An plus B upon n plus 1. Now we put the value of A1 and An from here and here. Okay, then it will be n by 2. What is the value of A1? An plus B upon n plus 1 plus, what is the value of An? An value is this much, A plus Bn upon n plus 1. Okay, here the denominator is same. We can take like this way, and an plus b plus a plus bn. Okay, now we can arrange it n by 2 into, we can take a and bn, an plus bn, and here plus a plus b upon n plus 1, upon n plus 1. So n by 2 into, we can take n common, a plus b, and here 1 common, plus 1 common, a plus b whole upon n plus 1. Okay, now what we do? Here we are just getting sum of the n term of arithmetic mean. We want to find the sum of n term of the arithmetic mean. It will be n by 2 into a plus b, and here n plus 1 upon n plus 1. Now n plus 1 and plus 1 cancel, and it will be n into a plus b by 2. Or we can say the sum of nth arithmetic mean, the sum of n arithmetic mean is equal to number of term into average of first term and last term. Okay, the sum of n arithmetic mean is equal to n into average of first term and last term. We can say here it is also proved, n into a plus b by 2, n times the arithmetic mean between a and b also we can say. Similarly, we can say that sum of the n terms is equal to n into middle term. If n is odd like that, the question will come, then we will discuss. Now this is the total theoretical portion related to the arithmetic mean, that how we find the arithmetic mean, and if we want more than one arithmetic mean, then how we find the sum of these n arithmetic mean according to this formula. Okay, let us see some question from the exercise 10.4. Let us see that with the help of exercise question. You must go through the theoretical portion properly and solve exercise questions. Before that, it will be better if you solve some example question of this exercise. Let us see the first one. Question is what? 10.4. 10.1. Find the arithmetic mean between -3 and 1. Arithmetic mean. We know that the question number first part, given number is what? Given number is -3 and 1. So here let a is equal to -3, let, and b is equal to 1. Therefore arithmetic mean is what? A plus b by 2. Its value will be -3 plus 1 by 2, -2 by 2, -1. It means here its arithmetic mean will be -1. Similarly, insert two arithmetic mean between -2 and 7. How we get this? In 2 marks question, this type of question may be asked. The second part of the question is what? The second part of the question, let us see. It is given here that insert two arithmetic mean between this. So let two arithmetic mean between -2 and 7 are A1 and A2, like that. Then arithmetic progression are -2 and 7, -2, A1, A2 and 7. Here total number of terms is n is equal to how much? 1, 2, 3, 4. 4 terms. The first term a is equal to -2 and the last term l is equal to 7. Okay, what we want to find? We want to find here the second term a1 and a2 because the question is insert two arithmetic mean between -2 and 7. The two arithmetic terms we just consider a1 and a2, then the required sequence -2 a1 a2 and 7, it will be in arithmetic progression. Okay, now the first term, total number of term 1 2 3 4, 4 term. First term will be -2 and last term will be 7. So we know that since L is equal to a plus n minus 1 into last term is given, that is 7. First term is given, that is -2, plus number of term is how much? 4. 4 minus 1 into d. Here if we transfer this through that side, so we get 7 plus 2 is equal to 3d. This implies that d is equal to 9 by 3 is equal to 3. It means the common difference of this arithmetic progression is what? 3. Then the second term, what is a1? a1 is the second term. a1 is equal to what? a plus d. Okay, what is a1? a1 is the second term because in this case -2 is the first term, a1 is the second term, a2 is the third term, and a7 this is the last term. We can say a fourth term. We can just explain it like a last term, okay, or we can say tn also. So here the formula is L is equal to or this tn is equal to, okay, since this is the formula. So a plus d, what is the value of a? Value of a is -2 and plus d, what is the value of d? That is 3. Then the second term or the first arithmetic mean is equal to 1. Similarly a2 is what? a2 is what? a1 plus d we can write. Okay, and what is the value of a1? Value of a1 is this 1 and value of d is what? 3 is equal to 4. First arithmetic mean will be 1 and the second arithmetic mean will be 4. We can use this formula also. A plus 2d, a is what? -2 and d is equal to 3. 3 2 is 6. Again here -2 6, value will be same. Okay, either we can use this formula or this formula. In both ways the value will be same. Getting? Similarly, these types of question is given in exercise 10.4. You should solve this question. Here question number 7 is based on example first. Example first, insert 6 arithmetic means between 2 and 16 and also prove that their sum is 6 times the arithmetic mean between 2 and 16. Similarly, here question number 7, arithmetic means are inserted between 7 and 71 in such a way. No, different question. Some more question is given like that. So go through this question. If you have doubts, then ask, okay? And I will try to give its PDF form also. Thank you.